Okay, just in time. Welcome to the second session of the afternoon. Next up, we have Matt Farmer from Greenlight Financial. He's the principal engineer in infra and operation, mostly focused on developer experience and tooling. And he's here to share how they implemented the decision logs and technical specs framework at Greenlight and how it helped moving faster when ensuring the impactful decisions were known to the right people. Critical when you're scaling, so it's going to be a great story. Thanks, Matt. Big round of applause, please.
All right. So as has already been said, I'm here to talk today about something that may or may not be interesting to you. It's definitely interesting to me, though I certainly do have coworkers that ignore my emails on this topic these days. And so, I am kind of eager to share. Before we get started, I'm just show of hands. I like to get to know the people that I'm speaking to. If you like pineapple on pizza, can you raise your hand? Brilliant. And then if pineapple does not belong on pizza at all. Okay. All right. Pineapple seems to slightly have an edge. This is going to be an interesting audience. I like that. I'm hoping we get a decent amount of a little bit of participation here. So again, I'm Matt Farmer. We're going to be talking about how we aim to move fast and decide things at Greenlight. I will preface this by saying we are in no way a perfect organization. Part of the component of this talk is to talk through some of the things that I think we can be doing better, and that is some of the stuff that I'm hoping to get to work on over the next year. But if you've never heard the term decision log, never heard the term technical spec before, we're also going to talk a little bit about what those are and kind of what's involved there. By quick way of agenda, this is the introduction. I'm going to talk a little bit about what led us to really start looking at these document shapes, these types of the needs that we were seeing in our organization. And then I'm going to walk through the decision log and technical spec formats, the kind of things that we make sure are included. And then we're going to end with a little bit of Q&A, and I am intending on sticking around for a little bit for anyone that wants to discuss after. My hope is that you walk away from this talk and feel like that you can either borrow the ideas that we've had success with and kind of learn from the things that I want us to see us doing better at. So, why did we start doing this? I like the phrase boil the ocean when talking about technical debt, because if you imagine that all of the code is an ocean, all of the documentation that kind of lags behind whatever you do is even harder to deal with. And this was true at Greenlight as well. We definitely had a lot of decisions, a lot of knowledge that was just trapped in people's heads, and it was really hard to revisit that. In addition to that, it was not always clear who had made a particular decision. So if you wanted to go get more information about it, if you wanted to talk to them or understand what part of the business and what their context might have been when doing that, it was really hard without writing anything down at all. Also, we were having a ton of meetings about the wrong things. I think this is something that a lot of people that are software engineers would likely resonate with. And specifically what I mean by this is we would come into these meeting rooms to have these really deep discussions on how we wanted to approach a problem or where we wanted to go strategically, and then everyone would walk out of the room with a slightly different understanding of what we had all decided to do. Throw into that all of the complexity that was going on related to being forced into remote work by the pandemic and all of the extra communication overhead that is involved there, coupled with the growth that we were really seeing at the end of 2020 and the beginning of 2021, you can imagine how these problems kind of start compounding on each other really quickly. And so a handful of us, of staff engineers, got together in order to really think about, okay, like there's clearly some problems here. What are some of the solutions? And two of the things that kind of came out of those discussions were our decision to start implementing a system of decision logs and technical specs. So you're probably rightfully asking, well, I haven't heard that term before. What does that mean? And the good news is that the documents are actually very similar in what they hope to capture. They hope to capture kind of a point in time reference, but what reference you're capturing there is a little bit different for each. For a decision log, we're really looking at those directional things that we want to do. It is not uncommon for the decision log to be a little bit aspirational, and the objective there is to explain where we want to be and why that's where we want to be, and kind of the other things that we considered and ultimately didn't pursue. If you zoom down a little bit into the day-to-day problem solving, that's where we deal more with the technical specs. The objective with these is to describe what a solution to a particular problem is going to be. It does not necessarily, in and of itself, endorse that solution for all future times that you come across this problem. It is a communication tool for a team saying, we need to do this. Here's how we're going to do it. Please give us feedback, and building that common understanding around what the approach is going to be. So I want to talk a little bit about what these actually look like in practice to help us kind of put our head around what I'm actually talking about here. The first thing is that there's some decent amount of overlap in the elements that you have in these types of documents. The first one is pretty straightforward. You kind of have this metadata. Who wrote the thing? Who's approving it? Who is actually, what is the scope of the thing, right? Like all of these kind of searchable attributes that you might want about the document. Unfortunately for my quality of life, our system of record is Confluence, and so we don't really have like a searchable database yet today, but the page properties and stuff is kind of the closest that we get there. And so that lets us build tables and lets people search and sort by the data that is in those, and gives us a pretty decent approximation. The other thing that you are going to want to make sure to include in documents like this are an objective or a problem statement. Many of the times in my engineering career, what I have seen is we end up getting sometimes distracted by the cool things we can do with some technology, and we lose sight of the problem that we're actually trying to solve. Having a clear and crisp statement of what we're doing at the top of the document really helps ensure that everyone is marching towards the same goal. And it's also helpful in the future when you go back to reference these things, because these are point-in-time documents, right? Like the idea is that once they're approved, they don't really change. They have a date attached to them. You can go back and understand how did they view the problem, and potentially, if it's a couple years down the line, their solution makes a lot more sense than it did before you read the document. But it's occurring to me that this is a little bit dry without a concrete example. I think anyone that works at Greenlight with me will tell you that I kind of love a little bit of controversy. If the pineapple question at the start of the talk was not an indication of that, then I don't know what to tell you. But I absolutely have a brand at Greenlight right now of putting in polls in our engineering team and picking like the perfect question that like evenly divides the entire engineering team and leads to some very entertaining discussions. And so I'm kind of hoping that we have a similar event here. And so I wrote a tech spec for this talk about something that's incredibly important to me, that is to make sure that it's done correctly. That is the correct way to assemble a bowl of cereal. Now, before going before an unfortunate night recently on TikTok, I did not realize that there was much disagreement on this topic, but even in the dry runs for this talk with the Datadog folks, there were people on the dry runs that were like, I disagree with this. And so I'm really eager to see like what kind of distribution we get from this so far. So what you're seeing here really kind of illustrates that metadata and how it looks for us. Whatever system of record you use will likely look a little bit different, but it shows you kind of some of the things that we capture about the documents. All right, so then we get into what I was talking about with regard to a problem statement. What is our problem here? We need to assemble a bowl of cereal and decide how we're going to do it. Straightforward problem statement. My recommendation for these is generally to keep them like 3 sentences or less. If you have to have more than that in a single problem statement, there's a very decent chance you're trying to solve too many problems at once, and that you should probably like box those off a little bit, right? Next, we've got the kind of objective block for the tech spec, right? So what are my goals? What am I actually trying to do? I want to assemble a bowl of cereal. Non-goals. So what are those things that I could do that I'm just going to say are not really in scope for this problem that I'm solving right now, right? And so I'm not going to tell you in this how to make the coffee to go with your cereal. You're going to be on your own for that part. Finally, anti-goals. This is one that I got a lot of questions about this when we introduced this term, but generally speaking, what are the things that if they happen out of this solution would be considered a deal breaker and would cause us to go back and reevaluate the solution from scratch? Like what is a possible outcome that's bad enough that makes us just go, nope, like we're going to go back to the drawing board? So then we move on to some of the more like meatier elements, right? Like those are designed to be very succinct and try to like help level set on where you are. Next, we have context. So a lot of times when the problem statement gets too inflated, what is actually happening is people are putting like a bunch of business or technical context in that problem statement, and it kind of muddies the waters a little bit. We pop that out into a separate section, and the goal is to describe like what technical or business context is relevant to the solution that you're proposing, right? It is probably not relevant what the weather outside my house is doing when I assemble a bowl of cereal. That is not something that I would include in context for this. Probably is relevant for other things. It goes for decision logs as well. If I'm making a choice about whether or not I want to support 2 languages or 3 in my organization, whether or not I can hire enough people to reasonably support those languages is important context in that case where it might not otherwise be. Assumptions and constraints. So this is where we really get down to what are those things that we are assuming to be true, even as we go about like proposing this solution or this decision. And what are some of the restrictions on the future impact? This is a slight variation of non-goals, anti-goals. So for assembling my bowl of cereal, context here is I'm hungry. Cereal is a delicious breakfast food that I would like to eat. I'm going to make the assumption when I write this tech spec that you already have a clean bowl, you already have some cereal, and you already have some milk. If you need to go to the store, that's not something this spec is going to help you with. This also does not handle the case that your milk has gone bad. It is going to be up to you to ensure that you have good quality milk with which to make your bowl of cereal, or I will not be held responsible for the consequences. And then we get into, all right, well, I'm solving a particular problem. What are some of the concrete things that go along with the specific problem-solving scenario? What are the risks that I need to consider? If we're doing software, virtually everything we do has some security or data or scaling risk that we need to consider. Those are all elements that we encourage people to fill out in the tech spec. What is the actual proposed solution? And what did I reject as an alternative to that solution? So this is my proposed solution for how to assemble a bowl of cereal, and I'm very eager to see what everyone thinks of it. But generally speaking, you find a bowl, you put some cereal in that bowl, and then you add an appropriate quantity of milk. You need to make sure that the bowl is correctly sized and what forth like that. But as I told someone that actually left a comment that I did not account for bowl size in this design, I said that's an implementation concern. And so this is our proposed solution as it stands. All right, so what are the risks? What could go wrong if we assemble a bowl of cereal in this way? Well, we have to assume that your doors are locked and a bear is not going to come in and steal your cereal. That would be an obvious security breach, right? We also call out, this should work for all quantities if you have a big enough bowl. I had to add that after the comment that my friend left. And finally, what are the rejected alternatives? What did we decide not to do? It is not acceptable to me that I'm just not going to eat a bowl of cereal right now. I don't have anything to eat before lunch, and I'm going to be in a foul mood if I am hungry in meetings. And that is just generally not good for my job future. And so one of the things that teams often forget to do when they're doing this is they forget to consider, what if we did nothing as an alternative? What actually happens if we do nothing? Why did we decide something had to be done? The other rejected alternative, and the point of controversy that got a lot of comments, is I refuse to pour milk into the bowl before the cereal. If I wanted to just have a ridiculous amount of milk, I would just drink a glass of milk. That would be sufficient for me. So that's the basic structure of a tech spec for individual solutions. For time's sake, we're not going to really get to walk through a full decision log example, but you'll notice that there are a lot of corollaries to our decision log format because it applies at a slightly higher level, right? So rejected alternatives becomes options considered. What did you actually, what is the full landscape of those things that you considered when you were doing this? And then the actual decision itself. And then because these are directional rather than a specific solution that you're delivering to a problem, there are almost always consequences to that decision that you have to consider. If we do this, we create this many tickets of technical debt in order to bring everything into line with this decision eventually. So that's the high-level overview of the shape of decision logs and technical specs that we use at Greenlight. So a little bit about how our implementation for this actually works. We introduced this around November of 2020. I think the big thing that gets called out again and again when I talk to folks about how well or how poorly this process is working is they drive home that the emphasis on lazy consensus has been massively important to keeping us moving quickly as we grow as an organization. If lazy consensus is a term that you're not familiar with, I was originally exposed to it from the documentation from the Apache projects. Effectively, lazy consensus means that if you put out a decision or if you put out a solution to a wide audience, give it some amount of time and nobody says anything, then you should take that as agreement with your decision and move forward. Generally speaking, it's really hard to get people to all explicitly thumbs up something But I think as engineers, we kind of all know that we're really willing to thumbs down something when we strongly disagree with it, right? That is really easy to get people to do. As I mentioned again, Confluence is our system of record. That means that we used Confluence templates to kind of provide this default document shape to everyone. You can get started really easily. New document, create a text spec, create a decision log, what have you. And we did a ton of active communication about when we introduced this format, like what problems they were solving to the org, stuff like that. In addition to those, we also were pretty clear about what the communication expectations are. So for our lazy consensus, we generally expect that for things that are going to affect, say, all of engineering, the expectation is you send that to all of engineering in email and Slack and give it about 72 hours. And if you've got crickets in response to that, you're generally in a pretty good spot to move forward. You almost never get crickets from all of engineering for what it's worth. But there's also like the leading by example was a huge part of it. The technical leadership group that originally worked on these formats started heavily using these pretty much immediately. And I can't stress enough like how important it is when working on cultural change like this, that a lot of times the benefit that folks are going to get out of it is something that they have to see rather than be told. So, as I promised, we're not perfect. What do we get right? What do we get wrong? Wins. We've got pretty good adoption of this within infrastructure, architecture, and several other groups within engineering. We also got rid of some of those meetings where we would walk away and have a different understanding. We had fewer surprises after we were done talking about something. My favorite way to put it is meetings that could be an email were now an email rather than having to sit in a meeting room. Yes. Whoever wooed that, I want to be your friend. That was great. In addition to that, we're also are slowly starting to build up this audit trail of point-in-time documents. So I used that phrase in passing earlier, but generally, just because there is an approved text spec that says this is how we're going to solve this problem, doesn't mean that problem gets solved that way immediately. The business context may change between when the time the solution was designed and the time that we actually sat down to implement it. We actually don't go back and update that existing text spec if that's what happens. We will mark it as replaced, and we link to a new text spec that documents the approach we were going to take. And that breadcrumb trail is massively important for us to be able to understand why decisions were made across multiple contexts at any given point in time. So what do we get wrong, right? We communicated a ton about this up front when we first introduced the formats. We did not do a great job of actually ensuring there was continuing training and education about this as the organization continued to grow. What this practically means is that for any given team or any given engineer in the organization, the opinion on whether or not a particular problem statement requires a text spec can be heavily informed by opinion or oral culture in that part of the organization and stuff like that. We definitely had some groups that leaned a little bit too far into the philosophy. They were sometimes creating these documents when Jira ticket would be fine. If you can describe everything you need to know about a change in a one-sentence Jira ticket, document format's probably a little bit overkill. And finally, we didn't really designate ownership over this thing. It was kind of this community project amongst the staff engineers for a long time. And I think that as we look forward to 2023, one of the things that I'm hoping that we do is we get to fix that, and we can actually put someone on first for kind of shepherding these formats and kind of the next iteration of them as we go. So, That's me. I am super interested for any feedback, questions. I always accept funny GIFs to my email account. If you have them, just happen to come across a good one, drop it to me. But yeah, at this point, I would love to answer any questions y'all have. Thank you.
If you have questions, please get up and go to the mic. There are a couple of mics on each side of the room.
And I will not be able to see your faces while you're asking the questions because of the spotlights. So it's going to be this really ominous, effect. Okay.
Right here. Hi, Matt. Thanks for your talk. I have a question about ADR. Have you ever used the architectural decision record frameworks, like with the command line interface and things like that? And when you were doing this, were you evaluating those? Did you decide on something else?
Yeah. So we had our own version of ADRs that predate this document format. I would say the biggest thing for us was ensuring that there was cross-functional kind of accessibility to these documents. These documents are not just for engineering, even if they are primarily contributed to and managed by engineering. Product managers need access to these. Designers need access to these in a way that makes sense. Frankly, the cognitive load of bringing in more tooling over what we already had was a little bit intimidating at the time. And so that was kind of a little bit of a stretch for where we were. Where we're going, we're a different organization today. It's very possible that something like that is in our future.
Thank you.
Yep. So a similar question. ThoughtWorks has their technology radar, and at least in so much as you're making decisions about tools, practices, did you guys consider either augmenting your process with that or bringing it in there?
The technology radar is something that we all stay aware of, but it would be a little bit burdensome to add it to every document and consider it for everything.
No, I was thinking more in the context of these are decisions that were made, sort of a broader view. If somebody comes new to the organization, what are the tools that are recommended? What's being deprecated?
Oh, sure. Yeah. So, I mean, when we're talking about decision logs that make a major technical decision, what is going on in the wider community is absolutely relevant context for that. Okay. It just depends on the scope and the breadth of what we're doing as to whether or not we bring in the tech radar in particular, or we bring in some other community kind of resources.
Okay, and last thought is on your serial protocol, it's incomplete for Lucky Charms.
What is my miss for Lucky Charms?
You have to eat about 3 bowls of cereal, removing the oats, before you finally get to the final bowl of cereal of marshmallows.
Okay, all right. All right, fair.
Hi, thanks for the talk. Could you talk a little bit about, with lazy consensus, the threshold where you don't get that if one person disagrees, or how do you handle that?
Yeah. So for most things, we have a pretty good idea these days of who the kind of owner of a decision would be at the end of the day. In the happy path, right? It's not controversial. We can kind of move along with the direction that the team has agreed on and wants to move in that direction. But at the end of the day, if it comes down to it, tech leads and staff engineers and other management within the organization are kind of empowered to assert that ownership and say, I hear what you're saying. Ultimately, my team is the one that's on call for this thing. I understand the risks and I'm accepting that risk, and we're going to move forward anyway. Or what most often happens is the tech spec is kind of iterated on and revised until there's less opposition to it. My favorites are actually when I publish a tech spec and then find out that I got something very, very wrong about my premise. And 9 times out of 10, though, we're able to kind of move forward without much controversy on these. Everyone at Greenlight generally has the same goal. We're all here to do a good job and do right by our customers, and folks understand that.
Cool. Thanks.
Thanks for the talk. So my question is around discoverability. As the organization grows and as the number of projects grow, there's going to be a lot of tech specs. I'm personally in document hell myself.
Yeah.
So how do you solve that search problem?
That is something that I would consider an unsolved problem at this point. This is one of the things that I think whoever we end up designating as kind of an owner of these formats moving forward really has to grapple with. We have some of that metadata that I mentioned before, but it's not super useful kind of in the Confluence document format we have today. And so my hope is that we can find something that provides some of that searchability, but still remains accessible to folks outside of engineering, right? Like there's like a balance there that we need to strike. And I don't know of anything off the cuff that's just pre-built that hits all the right notes for us.
How do you handle it right now with the, it sounds like this is apparently still a new process.
So we've had this process for 2 years at this point. So today, the kind of best solution that we have is to take advantage of labeling and tagging in Confluence. And so what we can do is generate reports of tech specs and break them down by what team they originated from and things like that, and filter by date range. So we have some of that, and we can lean on Confluence's kind of built-in searching and indexing functionality for some of that. But it's not what I would consider a long-term solution.
Thank you.
Hi, thank you for the talk. Wanted to ask, in your serial example, say that there is somebody that disagrees where they say, well, actually, we're defining breakfast here, and coffee is very important to my breakfast. So do you split that off into more technical documents? Does it balloon out? What is your preferred solution for that?
Yeah, so this gets back to the problem statement. What is your problem statement? Problem statement is, I am hungry. Coffee is not generally an accepted answer for I'm hungry, right? Like that's kind of, all right, like if we need a different like spec that's covering a different problem, that's great. Like we can do that. If we're really like defining something directionally, I would kind of make the statement like, all right, like this is bigger than just a solution to a particular problem. Let's bump this up to a decision log and really make the directional assertion on what needs to be included in this term.
Okay, thank you.
Hi there. Coffee can be an appetite suppressant, so if we delay it long enough, we might be able to use grilled cheese for lunch as our implementation instead. Have you considered that as an option? But more realistically, my question revolves around the questions and comments that you receive on these documents. Oftentimes, those comments take up visual real estate as well as reader comprehension and short-term memory real estate. How do you manage to strike a balance between keeping the comments and questions visible, resolving them, and incorporating them with these documents?
Yeah, so I would say this is another area where I feel like Confluence, they've not gotten the user experience right, just point blank. So the approach that we have taken so far is that when someone makes a comment, there's discussion that happens in that comment thread, and then when either the commenter is fine with the explanation in the comment thread, or we agree on some change to the document, we resolve that comment so that it's not taking up space, additional visual real estate on the document itself. There are obvious issues with that solution, right? Like it's really hard to go back and see what other people have commented on. And I've had more than one spec where I've gotten the same comment 3 or 4 times from different folks because that's this kind of system we've settled on. It's still a very squishy type of thing that we need to figure out in order how to do better. Where possible, I try to either add a document comment at the bottom if something keeps coming up, or make an alteration to make the language of the spec more clear so that the same issue doesn't keep popping up.
Awesome. Thank you.
Yeah. So far, nobody has confessed to putting milk in their cereal bowl first. This is fascinating to me.
Hey Matt, great talk. Got a question. So basically, I'm assuming that the tech spec has been created before the implementation phase started, and how do you handle a blocker or a dependency on some other thing when you see something at the time of implementation? How do you make sure the tech spec document is updated?
Sure. So my tongue-in-cheek answer is that's the problem for the engineering managers to figure out. My serious answer is it depends on how far you're really diverting from the spec, right? Tech specs don't include like specific lines of code in them generally. It's higher level than that. So it depends on the nature of what you're running into. If it's significant enough that it involves totally changing the design, then yeah, like during the implementation phase, you would basically replace that tech spec with a new one that describes the updated solution and get whatever feedback you need.
But most of the times, developers won't be updating the document. And how do you make sure that happens?
There is no substitute for cultural reinforcement at the end of the day, right? So, yeah, like there are places where it has not happened perfectly. There's no perfect kind of PDLC hook for you must go back and update these documents. It really is. It has to be driven by like the cultural buy-in on the format and the methodology.
Thank you.
So you mentioned that one of the problems were engineers leaning in too much into it and creating a doc instead of a Jira ticket.
Sure.
So I was wondering what was the initial guidance and guideline for when to do it and when not to create a design document?
Yeah. So the guidance that I still give today on that is that if you can describe, like if your Jira ticket is like 2 sentences and some acceptance criteria, you're probably not doing anything sophisticated enough to warrant a full document review or stuff like that. Right? Like there's this class of things that are incremental that we do all the time. And if we stop to do documents for every single one of those, it's going to really slow everything down. I kind of look at it like they're basically 2 inputs, right? What's the complexity of what you're doing? And what's the blast radius of what you're doing if something were to go wrong? If either of those ends up being pretty high, right? So like if it's very complex, your Jira ticket gets very wordy very fast, and like that's a good hint. If it makes you nervous to think about what else could break because of the number of things you're going to have to touch, that's a good indication that you're probably crossing that blast radius scale. If you trigger kind of either one of those, that's when I generally default to saying, all right, let's write a spec for it. Let's get input from folks that have context we don't and make sure that our bases are covered.
Makes sense. Thanks.
Mm-hmm.
Great talk. Thank you. In my project, my architect is kind of preaching rather.
I'm sorry. Can you speak into the microphone a little bit more? I'm having trouble hearing you.
Okay. My architect is kind of, suggesting creating Confluence documentation with C4 diagrams. Have you considered those, like context and component diagrams, and have you evaluated those diagrams? What's your take on this?
So I want to make sure I understand the question. You're asking, have we evaluated using auto-generated diagrams or manually generated diagrams as a part of the tech specs?
Yeah, they can be manually generated, but more of architecture kind of diagrams like context diagrams, component diagrams, class diagrams.
Sure. So I don't feel the need to really be dogmatic and like say you must have all sorts of these diagrams. Like that tends to become a little bit overbearing over time. But for solutions that are introducing a new data model to the product, those types of like relationship diagrams and entity diagrams and stuff absolutely do appear. That is less common kind of in the infrastructure and ops domain because most of what we're doing is not really changing the schemas on the production data store, but we see it a lot in the stuff that comes out of product engineering.
Okay, thank you.
All right. Thank you, everybody.